Chapter 23 Physics, Theory Video 5. So now we are going to compare capacitors and resistors. Like I told you earlier, it is going to be a little different. Their connections are different. Now, in capacitors and resistors can be connected in series as well as in parallel as shown here. Then in capacitors in series, we get the reciprocal sum, but in resistors in parallel, the reciprocal sum would be applied. For example, for this one, the equation is 1 upon C total equals 1 upon C1, etc. Right? For this, it would be 1 upon the resistance 1 upon R total is equal to 1 upon R1 plus 1 upon R2. So there is the relationship is like this. For parallel capacitors, total capacitance is equal to C1 plus C2 plus C3. For series resistors, it is R1 plus R2 plus R3. I hope that makes sense to you. So, now capacitance would give us an idea how much, how good a capacitor is to store a charge given a voltage, and resistance would indicate how bad a resistor is at letting current through for a given voltage. That is, how much it is not letting current pass through if a voltage is given, right? So that is the relationship here. So now we are going to deal with capacitor networks. So in the first one, A1, as you can see, it is connected all in series. Then how are you going to get the capacitance total? 1 upon C1 equals 1 upon C2 plus 1 upon C3. Then in the part B, B diagram here, we can see that it is in parallel. Therefore, we don't deal with 1 upon anything. We just add C1 plus C2 plus C3. Then in C, it is a little bit more complicated because we are having 2 in series and the other one in parallel. Then you get a different formula. In the other one, there are 3, 2 are in series and another one in parallel. So these are different ways how we have to obtain. So in figure 20.14a, it is simply 1 upon R for A1, 1 upon C total equals 1 upon C1 plus 1 upon C2 plus 1 upon C3. For B, it is C1 plus C2 plus C3. I suppose you understood that. Now, when it comes to 23.1 for C, calculate C total for the two capacitors of capacitance C1 and C2. So for C1 and C2, they are in parallel. So as a result, we add them together, C1 plus C2. Then we add it together. Then we take the series one. That is what how we are going to do that is, then for these two alone we can get C1 plus C2. Then after that we need to add the C3 part. Then we get 1 upon C total is equal to 1 upon C1 plus C2 and plus 1 upon C3. I hope that makes sense to you. Because these two are in, now this if you take as one unit, these two are in series. So as a result, you get it like this. If you have any doubts, please raise questions. Right. Then for the other one, you first find C1 and C2 and then add it to C3. That is what you do. C1 and C2 you add it by taking 1 upon C1 plus 1 upon C2, and after that you add it to C3. Let me do and show you. So because C1 and C2 are in series, we know that 1 upon C total for those two alone is equal to 1 upon C1 plus 1 upon C2. Then for the entire thing, you get this, and to that you add C3. I hope that makes sense to you. Then moving on to the question 15, 16, 17 and 18, please do them. And if you have any further questions, please ask. Right, then let's go to sharing charge and sharing energy. Then if a capacitor is charged, now what we do is we charge a capacitor and then we connect it to a second capacitor. What is going to happen? When capacitors are connected together, they are when they are in parallel, because they are going to have the same PD across them, right? When the capacitors, when we connect capacitors together, they are going to be in parallel because the potential difference is going to be equal. Then what we do is, because they are in parallel, we know that their combined capacitance is going to be the individual capacitances, right? Then if we think about the charge stored, that is Q, this charge is going to be shared between the two capacitors. So that means the total amount of charge should remain the same because the charge is going to be conserved. So as a result, the two capacitors are going to share their charge, but that will depend on their capacitances. So we get the PD V equals Q upon C, and we have an equation for energy, W equals a half CV squared. So then what happens is we can actually represent this using a containers of water, right? So here the width shows how much of a capacitance it has. So in the first one, in the first diagram, as you can see, only one is charged. Then that is that it has a higher capacitance. This one has a higher capacitance. It is connected to another capacitance which has a smaller capacitance. So then what happens is the levels, when it is connected, what happens is there is a net flow of charge from the first one to the second one. As a result, what has happened is the potential energy of the water has decreased because the height has decreased. So just like that, the potential has decreased in the capacitors as well. Then what happens is then it flows through, because the potential difference is going to be the same for each. Potential difference is going to be same for each. Now the potential has decreased. Then energy is removed as heat when this charge is moved from the first capacitor to the other. So that is how it happens. Now let's look at the worked example here, then you would be able to figure out what they are talking about. 200 microfarad capacitors are taken. One is charged to 10 volts, disconnected from the power supply and then connected across the other. Calculate the energy stored by the combination. So first of all, we have to calculate the charge using the equation Q equals Vc, and then using the energy. Q equals Vc, V is 10 into 10 into 0.10, 10 into 0.10, then we get voltage is 10 capacitance is they have given in millifarads, rather millifarads, not micro, millifarads. So as a result it is going to be 0.10. That would give you 1.1 coulombs. The charge is going to be 1 coulombs. Please don't mistake this this C for this C stands for capacitance. This C stands for coulombs, right? Please don't misunderstand those two. Then we use them, then we get 1 coulomb as the charge. Then the stored energy is going to be half CV squared. Here the once again C stands for capacitance, because in equations we don't say coulombs, therefore it is always capacitance. Then half into 0.10 multiplied by voltage squared 10 squared, then it is going to be 5 joules. Now we know that because it is connected in parallel, they have said because when they connect, they are connected in parallel. That is an assumption that we need to have. And also they are connected across the other, that is connected in parallel. So as a result, we can get C total to be C1 plus C2, which is going to be 100 plus 100, which is going to be 200 millifarads. Then again we can use V equals Q upon C to find out the voltage across them. Then we get 1 over 200. We found the charge to be 1 coulomb. 1 over 200 into 10 to the power minus 3 gives us 5 volts, because the charge is shared equally. So as a result, what has happened is the charge that it had earlier, 10 volts charge, is shared between the two as 5 volts. Then the total energy stored by the capacitors, we go for total energy half CV squared. Then half into, now the total capacitance is 200 multiplied by 10 to the power minus 3 into 5 squared, then it is going to be 2.5 joules. Then the charge stored remains the same, but the energy is going to be half. That means the half of the energy is lost. So the energy is used as heat energy, or lost as heat energy, when these electrons are migrated from one capacitor to the next. I hope that makes sense. Please do question number 19 and 20. Then we will we will be able to understand it better. If you have any questions, please raise them. First, let's write down a note. Write down, when capacitors and resistors are compared, they have a relationship that extends as an inverse relationship, right? I hope that makes sense, and I hope that you understand what it means. That is the series series in capacitance is equal to the parallel in resistance, and the resistance parallel is equal to the resistance parallel is equal to series in a capacitance. So this is the relationship it has. This is similar to this, and this is similar to this, right? I'm not going to bother too much about this. I'm going to move on to the next part. Please draw this capacitor network. Please draw this, and then write down how we calculate them. For A, I'm going to show how to do that. A, because it is in series, 1 over C total is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So that is for the first one. After drawing, pause the video and draw them, and then write this how to calculate them. So that is for A. Then for B, let's do for B. For B, because it is in series, because it is in parallel, it is quite easy. C total is equal to C1 plus C2 plus C3. Right. Then for part C, first of all we have to get these two. First we have to calculate for these two. Then it is going to be C total is going to be C1 plus C2 for these two. After that, you get it as for the entire thing you have C total equals 1 upon C1 plus C2, then plus 1 upon C3, because those two are going to be in series then. I hope that made sense to you. Then we go to part D. First we have to deal with these two, C1 plus C2, because they are in series. You add 1 upon C1 plus 1 upon C2, and after you get that, you add it to C3. Simple. I hope that made sense to you. Then let's do question number 15, 16, 17 and 18. Then leave a line and write. When a single capacitor is charged and connected to another capacitor, they would be in parallel because they have the same PD across them, and their combined capacitance C total is equal to the sum of their individual capacitances. The charge Q would be shared between the two capacitors. However, the energy would be dissipated when this sharing is done, which can be explained as follows. And I want you to write down this worked example. Only this worked example. Other worked examples you don't have to write down. Just write this down, because this is the best example, the best explanation that we can give to explain how this works. And once you have done it, once you have completed that, please go to question number 19 and 20. Then in the next video we will discuss the remaining part of this lesson.